Chapter 6 is about exponential and logarithmic functions. Now, exponential functions you probably saw before in Algebra 1. Logarithms is going to be something completely new, so we got a couple days before we get to that stuff. But what we're going to look at today is just this idea of exponential growth and decay. And you know, I teach this in my Algebra 1 class, so hopefully this is a little bit of review for you. So what makes a function exponential is that the variable is the input of the function. So you can see here the input is actually the exponent. So for example, you might see something like y equals 2 to the x. It makes it exponential because the unknown, the independent variable, what we're changing, is going to be the input of our function. That's going to be where the x is. And so exponential functions are in the form y equals a times b to the x. And there's two different types. It can be exponential growth, which means it's getting bigger, or it can be exponential decay, which means it's getting smaller. And so when we look at this, if the b is bigger than 1, that's what's going to make it growth. And if the b is between 0 and 1, that's what's going to make it decay. And so we only look at the b part. So for example, if we look at these down here and try to decide which is which, this says y equals 2 to the x. Well, that we can think of as 1 times 2 to the x. So we can see here that the b is 2, which means that this is exponential growth. If we look at example B, we can see this is 3 times 0.12 to the x. That means b is equal to 0.12, and since that's between 0 and 1, this one is decay. So take just a second to kind of think about C and D and decide what you think the answer is going to be for each of those, growth or decay. So don't get in the habit of just looking for fractions, because in this case, b is 3 over 2, which is 1.5 or 1.5. So that's actually bigger than 1. So that makes example C growth. And then for D, don't get distracted by A, because the 1/3 here is A. B is actually 5, and so this one is also growth. B stands for base. It's the base of your exponent. So whatever the base of the exponent is, that is B. That's what you're looking for. Okay? So growth and decay, that's all great. Let's talk a little bit about what those things actually look like. So there are two different parent functions, because exponential growth looks one direction and exponential decay looks another direction. So if you look at exponential growth, it's this sort of smooth curve. It's almost like a bent line. And so when b is greater than 1, it's going to look like this. The graph rises from left to right, and then it's going to have what we call an asymptote, and this may be the first time that we've heard about this before. An asymptote is an invisible line that the graph approaches, but it never actually gets to. And let's think about why it would never actually get to there. So if I have, let's just say y equals 2 to the x. Let's just think of a small base here. So if I do, let's go in reverse. If I do positive 2, I do 2 to the second power, which is 4. If I do positive 1, that's 2 to the first power, which is 1. I'm just kidding. It's 2. If I do 2 to the 0 power, remember anything to the 0 power is 1. And then I start getting into negative exponents. Negative exponents flip over. So 2 to the negative 1 is 1 over 2 to the first. 2 to the negative 2 is 1 over 2 to the second, which is 4. 2 to the negative third is going to be 1 over 2 to the third, which is 8. Now notice my fractions are getting smaller and smaller and smaller, but I'm always going to have a fraction. When I get to negative 10, I'm going to have 1 over 2 to the 10th power. That's going to be a really small fraction, but it is still going to be something. So there is no way that you can actually get to 0 here. And so the way we show that on the graph is by sketching a dotted line through 0. That dotted line is the asymptote, and that shows that my graph is going to level out next to it, and just keep getting closer and closer and closer, but it never actually gets there, okay? And so since it never gets there, if we talk about the domain and range, I've got arrows going to the left and arrows going to the right, so that means that my domain is going to be all real numbers, but because the graph never gets to 0 and it never goes below 0, its y is greater than 0 for the range. Notice it is not equal to, because it won't ever get to 0. It's going to get closer and closer and closer, but it's never going to actually get there. Now, if we look at exponential decay, that's going to do the same thing. But if my base were a fraction, let's look at 1/2, for example, this time. If I have y equals 1/2 to the x power, well, now if I start with my negatives, -3, that's going to flip over the 1/2. So now it's 2 to the third, which is 8. -2 is going to be 2 to the fourth, which is, or 2 to the second, which is 4. -1 is going to give me 2. 0 still gives me 1, but now my positives are where I'm going to get the fractions. 2 is going to be 1/4, and so on. So it starts with the bigger values and works its way down to the smaller values, okay? But the same is true. There is going to be an asymptote, and I'm never actually going to get to 0. And so in this instance, the domain and the range are the same. So let's talk about how to graph these. So the first thing we want to do is decide whether the function represents exponential growth or exponential decay. Then we want to graph the function. Make sure that you sketch the asymptote. You should have a dotted line on every single one of these graphs. And then we want to state the domain and the range. So since we're just working with parent functions right now, and that's what's sort of interesting about these, is it's the parent function is y equals b to the x. Well, b can change, so that means there's a whole lot of different parent functions depending on what the base is. So for example, a, that's a parent function with base b. For example, b, that's a parent function with base 1/2. Sorry, the first one was base 3. So the base can change and it will still represent a parent function. So that's a little bit unique. So what we're going to do is we're going to set up a table, and because I'm kind of pressed for space, I'm going to do a horizontal table here. So what we want to make sure we do, a good range is going to be -1, 0, 1, and 2. That will be plenty for me to get a good idea of what the shape is. So 3 to the -1 power, remember that's going to flip over, so I get 1/3. 3 to the 0 power, anything to the 0 power is 1. And then the rest of them are pretty easy. 3 to the first power is 3, and 3 to the second power is 9. So let's sketch what that looks like. -1, 1/3 is going to be about here. 0, 1 is going to be here. 1, 3, and 2, 9. So you can see exponential functions, they grow relatively quickly. They start off kind of slowly and then they pick up. My next one would be a clear up at 27. So it's almost 3 times as high as what the graph is that we have now. And so this is going to come down like this, but remember it never gets to 0, so it's going to level off at the end. And then we can sketch our asymptote here on the x-axis because it can't pass 0. It's kind of hard to draw the asymptote over the x-axis, so if you put your dashes just a little bit below, kind of like I did over here, you can see it a little bit better. So now we want domain and range. So the domain for each of these is going to be all real numbers because we have arrows on both sides. And then if we look at the range, the asymptote is at 0, and then my graph goes above that, so this is going to be y greater than 0. Remember, not equal to, because you can't actually touch the asymptote. It's a boundary that we won't ever get to. Okay, so let's look at, and it asked us whether this was growth or decay, and this one is growth because b is 3 in this case. So the second one, because b is 1/2, this one is going to be exponential decay. And same thing, we want to set up a table. Now, when we do negative exponents of a fraction, it just flips your fraction over. So 1/2 to the -1, 1/2 to the -1 power makes it 2/1. 1/2 to the 0 is 1, 1/2 to the first is 1/2, and 1/2 to the second power. Remember that when we square a fraction, that means we do 1 squared over 2 squared. So that's just 1 over 4. And so we can sketch that. So negative 1, 2, whoops, negative 1, 2, 0, 1, 1, 1 half, and 2, 1 fourth. So you can see there. And if you wanted another point, maybe plug in negative 2. That would give us positive 4. That gives us a little bit better idea of what the shape is going to look like. And then don't forget to sketch your asymptote right here. Cha-cha-cha. And so for this one, the domain and the range are exactly the same. The domain is all real numbers, and then the range is going to be y's that are greater than 0. And that's all that we're going to do for today. We'll talk about this in a little bit more detail tomorrow, or Monday, and I will see you guys soon. Have a great weekend.